we're going to continue our discussion on the ARIMA process. Okay, autoregressive integrated moving average. Okay, I'm looking at the file that I sent you in part 2. Okay, we were not able to finish this. So far, what we have discussed is that ARIMA, the ARIMA process is used to model your time series, to forecast your time series. So this was developed by Engel in 1970s, okay? And then it was improved on. Sino nag-improve niya, guys? Sorry, I got confused. No? ArchGuard ang iniisip ko. So si Box and Jenkins, no, sila yung sila yung nag-develop yung ARIMA process, no? Autoregressive integrated moving average. And we said that the first requirement for us to model a time series using ARIMA is that the data has to be stationary. Sabi natin, ang ibig sabihin ng stationary in mean, ibig sabihin walang trend. The data is not going up or going down. And also in variance. Dapat constant yung variance. Or usually may seasonality, no? Or multiplicative seasonality. Nag-i-increase yung variance over time. May fanning out or fanning in. Okay, so we said that we cannot model a time series if it's not stationary. We have to convert it into a stationary data first. So how do we convert a data to become stationary? Depende kung saan siya hindi stationary. If there's a trend, so hindi siya stationary in mean, di ba? So anong ginagawa natin para maging stationary siya? I-difference natin. Pag dinifference natin, usually natatanggal yung ano diyan, natatanggal yung trend. Okay? So when that happens, when we difference the data, so nawawala na yung trend, so nagiging constant na siya in mean, then that difference data can now be used to be modeled as an ARIMA process. Okay? So take note guys, pag nag-difference tayo, ibang data na yung tinitingnan natin, hindi na yung original. Okay, so ang i-interpret natin yung difference data. But there's a way of course to relate it back to the original. Okay, pangalawa, pag may seasonality guys, okay, pag hindi constant yung variance, anong ginagawa? Okay? How to make it constant in variance? You get the log. Pag kinuha yung log, usually na-address na kagad yung ano. Paano kung hindi stationary in mean and in variance? Okay, there are several ways to do that. One could be first get the log. Okay, and then get the difference. So iba naman minsan kinukuha yung difference and then get the log. The only concern about getting the difference first and then getting the log is that kung yung difference data natin may negative na, magkakaroon ng negative values. Pag magkaroon na ng negative values yan, hindi mo na pwedeng kunin yung log niyan. So you will have to adjust the data again. Diba? Kasi you cannot get the log of a number. Okay, so ang ginagawa ng iba, assuming na positive yung mga values, kinukuha mo na kagad yung log. Okay? By getting the log, na-address yung non-constant variance and then get the difference to address yung non-stationarity in terms of mean, mean. Okay. All right. So that summarizes, guys. So, pag stationary yung data natin, how do we now determine kung anong process ang pwede sa kanya? Okay. Before nung wala pa mga software na ganito, okay, you will have to plot the ACF and the PACF. The autocorrelation function and the partial autocorrelation function. Okay? So dinefine na natin kung ano yung autocorrelation function. Sabi natin dito, it's a bar chart of the coefficients of the correlation between a time series and the logs of itself. So kunyari, yung original data natin. Tapos kukunin natin yung correlation niya with log 1. Okay, so correlation ng data at saka ng log 1, yung past values niya ng 1 log, no? Kunyari, ngayon hanggang a certain date in the past, tapos kukunin natin relationship niya at saka yung kahapon up to certain data in the past too. So dapat pareho yung dapat pareho yung pareho dapat yung size ng data natin. Okay? So, and then guys, so that's log 1. Tapos kukunin mo naman yung log 2. So, yung value natin ngayon hanggang dun sa dulo, tapos yung 2 days ago, ko-correlate natin siya sa 2 days ago hanggang dun sa dulo. Magkakabawasan nga lang ng data points. No? Okay, so that's what an autocorrelation plot gives us. So sabi natin, when you plot the ACF and the PACF, malalaman natin kung AR process ba siya or MA process. No? We use the ACF to determine kung autoregressive yung process. Again, ano yung ibig sabihin ng autoregressive, guys? We are modeling our data based on past values of itself. No? Sarili niya, auto means self. So y sub t is equal to a certain constant mean alpha sub o plus alpha sub 1 times y sub t minus 1, etc. So ginagamit natin yung past values ng data natin para ma-model natin siya. Okay? And of course, usually guys, yung mga recent past, sila yung may mas may malaking impact dun sa data natin, no? Compared to kunyari, yung data natin daily, 10 years kunyari. Siguro wala namang impact yung data 10 years ago, no? Yung January 1, let's say 2010 kaysa sa January 1, 2020. No? Siguro yung data ng January 1, 2010, wala na masyadong impact yan sa January 1, 2020 kasi masyadong malayo yan. No? Pero yung December 31, 2019, maaaring malaki yung impact niya dun sa yung log 1 values. No? Okay? Or log 2 or log 3. Okay? Yung mga close, yung mga malalapit na mga log, sila yung may malaking impact dun sa model natin. Okay? So yung ACF natin, ipa-plot natin yan. Diba? If you recall guys, ginamit natin si PSM package. Okay, nung ginamit natin si PSM package, automatically pina-plot kagad si ACF at saka si PACF. Okay. If you want to know if it's an AR process, then you look at the PACF. Pag may significant spike in certain logs, okay, then that indicates that this could be an AR process. On the other hand naman, si MA, tinitingnan natin yung PACF, yung partial autocorrelation plot, yung correlogram na yan. So kung may significant spikes, ibig sabihin significant spikes, kunyari sa log 1, significant yung niya, dun sa bar plot, no? Tapos the rest, wala na, hindi na significant. Okay? Alright. If you take a look at the ACF, tapos may significant spikes, it's indicative na MA process siya. Pag ganun pareho yung ACF at saka PACF, then that's indicative that it's an ARIMA process. Okay? Pag yung ACF lang yung may significant spike, tapos si PACF slow decay siya, then indicative yun na MA process yan. Okay? I hope you're getting me, guys. Let me write that. No? So again, tingnan natin ha. ACF. Sa ACF, guys, significant spikes. No? May spikes dun sa mga some logs. Tapos, yung PACF natin, slow decay. Alala yung slow decay natin, yung hindi significant spike, yung parang dahan-dahan bumababa yung tapos pwedeng aakyat, slow decay ang tawag doon. Then this is a signal na MA process yan. Candidate yung MA process. On the other hand, guys, baliktad siya. PACF natin, significant spikes, ACF natin, slow decay, then that indicates that this is an AR process. Okay, PACF, significant yung spike, ACF, slow decay, then most probably this is an AR process, autoregressive process. By the way, ano yung MA process? Sa MA process, guys, what we're modeling is y is equal to a certain constant, no? plus b1 times epsilon t minus 1. Epsilon is the error term. Okay? Yung error ang minomodel natin, yung difference ng actual value at saka yung average value. Okay? Yun ang minomodel natin pag MA process. Now, pag parehong significant spike dun sa ACF at saka sa PACF, then that's indicative that this is an ARIMA process. Okay? Alright. Kailan naging ARIMA? ARIMA process, guys, pag yung original data, dinifference natin. Ibig sabihin, dinifference, minus natin yung value at time t dun sa value at time t minus 1. So that will become an ARIMA process. No? Okay. Pag ARIMA process, guys, ang ginagamit pa rin natin yung original na data. Okay? Pero pag nag-difference na tayo, tapos ang gagamitin natin yung difference data, then magiging ARMA na lang yon, no? I hope you got me, no? Sa ARIMA process, ang minomodel natin is the original data, no? Na dinifference siya ng isa. Kung ARIMA, let's say, P1Q. Pag ano naman, guys, pag kunyari, dinifference na natin siya. Kunyari yung AP natin na data. AP, yung airline passengers. And then, dinifference natin siya. No? Okay, dinifference natin siya. We created an object called DAP. Okay, DAP. So, naka-difference na siya. Tapos, pag binodel natin yon, tapos lumabas na ARMA siya, then, ang tawag na natin dun, guys, ARMA na, ARMA. Bakit nawala yung I? Or ARIMA, kunyari 101. Bakit nawala na yung 1 na difference? Kasi, ang ginagamit na natin ngayon, yung difference na data. Unless na i-difference mo ulit yung difference data, then saka siya magiging ARIMA ulit. No? Okay, clear ba yan, guys? Pause muna ako kasi baka malabo yung pag-explain ko. No? Are there any questions, guys? Chat naman, please. Clear ba o hindi? O may questions? Kasi pag wala nag-chat, ibig sabihin, guys, baka likely yun na magulo yung pag-explain ko. Clear? Thank you. Thank you, Pero pag may questions kayo, guys, please feel free. No? Feel free. I'd like to encourage that. Okay, sige. Thank you. Thank you. I hope that's clear. Okay. So let's continue our discussion on this. Okay, ang objective natin, guys, given a time series, ma-model natin siya. Kung AR ba yan o MA ba yan. But before we do that, let's take a look first at yung sa stats package. No? Meron sa stats package yung ARIMA.sim. So sige nga, guys, hanapin natin to ARIMA.sim. Tapos question mark natin. Let's take a look at this function. Okay, so this is from the stats package. Ito, no? Okay, so what does this do, guys? Itong function na to. It will simulate an ARIMA model. So ito yung syntax niya, no? Model and random generator, kung normal distribution, etc. No? So ito yung ano natin, yung ARIMA.sim. Tapos may example siya dito, no? We're not going to use this example. So magkakreate tayo na example natin. Okay, so gamitin natin, guys, yung ARIMA.sim from the stats package in order to generate data set that we can model using ARIMA. No? Okay, take a look at this. Set.seed. So mag-set.seed tayo, guys, para pare-pareho tayo. No? Okay, we're creating an object called sige, x1 na lang. No? x1, then ARIMA.sim. Okay, ilang observations? Let's create 1,000 observations. And then ililist natin, guys, ano yung AR component at saka yung MA component. Okay, ano yung AR component at saka yung MA component. Okay, so you have here AR. So ito, dalawa yung linilist natin dito, no? 0.889. So this is your AR1 process and this is your AR2 process. Dapat guys, yung ano dapat yung mga ano natin yung A1 at saka A2, yung AR1 process and A2 process should be less than 1, no? So dapat less than 1 siya. So 0.8897, okay. Negative 0.4858, okay. Tapos dapat yung sum nila, guys, should be less than 1. So 0.8897 plus negative 0.4858, okay. So less than 1 yon, so we're okay. Okay itong mga A1 at saka A2 na ano natin, coefficients. Ganun din guys kay MA process. No? Si B1 and B2, individually they should be less than 1 and collectively guys dapat less than 1 sila. Okay? So we're also giving a standard deviation. Okay, and then i-print natin to. No? I-print natin yung first 10 observations. So let's run this. And we should have the same figures. No? Okay, guys? Pareho ba? Pakichat guys kung pareho yung data natin. I-view nga natin si X1, view, X1. Okay, so ito yung na-generate natin na ano, na time series. No? Ito. 1,000 observations. And we should have the same values because, guys, di ba, nag-set.seed tayo. Okay, so, all right, i-plot natin, guys. Okay, let's call the object xplot. I-auto-plot natin si x1. Mag-skip na ako dito. Okay. Oops. Ano to? Wait ha. Hindi pa pala natin inaano. Wait. Anong package to? Hindi ko pa pala. Sorry guys ha. Kailangan i-library muna natin si ano, ggplot2. Autoplot is from ggplot2. Okay, thank you for the feedback. Good. Pareho tayong data. And then, kasi hindi ko pa na ano, no? Lagay ko nga dito ggplot2 para you know kung saan galing package to. And since wala pa tayong na ano wala pa tayong palang na load na package. Okay, so let me run this. Okay na yan. All right. Take a look at our data, guys. Okay, what can you say about our data? Is it stationary? Constant ba yung mean? May trend ba? Chat please, guys. Constant ba yung mean? Guys, constant ba yung mean? But if you take a look, guys. Ba? Hindi naman, wala naman trend yung mean. Hindi naman siya gumagano, di ba? O hindi naman siya bumababa ng ganun. Diba? So it's constant over time. Okay? In fact, ang mean niya, di ba, 0. Yan. Diba? Nag-aano lang siya. Akyat, baba, diba? Right? Okay. MIGS, bakit no? Would you like to explain MIGS? Bakit hindi? MIGS, can you hear me? Okay, wala yata si means. Okay, so constant yung mean, guys, no? Tapos, constant ba invariance? May nakikita ba tayo ng yung variance, it's increasing over time ba? Gumaganon ba siya? Ganun ba yung ano? Gumaganon ba yung trend ng variance natin? Over time, nag-i-increase siya? No, no? It's not increasing. No? It's not increasing over time. So we can say, guys, that it's constant in mean and constant in variance. And we expected that, guys. Kasi yung plot natin, yung data natin, it was generated out of an ARIMA model. Okay? Ito nga yung parameters niya. And sabi natin, di ba, pag ang ARIMA, guys, not necessarily dapat yung model natin stationary. No? Okay, so we were able to draw out, we were able to come up with a data set, no? Using this set.sim at saka ARIMA.simulation, ARIMA.sim. Okay, so tingnan natin ano yung average mean ni X1. Tingnan natin kung ano yung average niya. So practically 0, no? Tapos ano yung standard deviation ni X1? Standard deviation niya is, ano ba yung SQRT ng 0.1796? Okay, square root nun is 0.4, 0.42. So, okay, so medyo may kalayuan, no? 0.54 yung lumalabas na square root ng X1 natin. Pero yung square root nito, square root niya, 0.1796 is 0.42. So there's a discrepancy there. But that's okay, guys. No? Simulated lang naman kasi itong value na to. Okay. Now, remember, guys, we can check. No? I-load na natin library, guys. Library, TSM. TSM. And then, i-plot natin to. TSM package, di ba ito yung function natin, autocorrelation ni X1 max.log is equal to 30. So let's run this. Okay. Okay, what do you notice about our plot? What do you notice, guys? Okay, taking a look at the PACF, guys, this is indicative na ano siya, no, na na possible na ano siya, AR process, no? Kasi significant spike here at log 1 and then significant spike here at log 2 and also at log 3. In fact, yung model natin AR2, di ba? So as can be seen here na significant siya at log 1 at log 2 and in fact kahit sa AR sa third log significant din siya, no? And since simulated lang naman yung na-generate natin, pwedeng pag minodel na natin siya, baka pwedeng either AR2 lang or AR3. How about, guys, sa ano? How about sa MA model? Okay, di ba titingnan natin sa ACF? Okay, ito parang ano siya, no? Parang may slow decay siya, no? Although may mga significant spikes siya dito sa log 1, log 2, log 3, log 4, log 5, may mga significant spikes siya dito eh. Okay, and then dito din sa ano sa yung higher logs, no? So possible na MA din to. Okay? Possible na MA. So ganito dati, guys, yung pag-determine ng model, suntok sa buwan, parang trial and error. Pero ngayon, guys, meron na tayong auto.arima na function na given the time series, si R na mismo ang magsasabi sa atin kung ano yung best na ARIMA function. So we're going to look into that, no? Pero tapusin muna natin to. I'm not sure if we'll be able to cover that. Pero definitely sa next session, guys, magdi-discuss natin yung auto.arima. Okay. All right. Ito na, hindi na kailangan to, no? Hindi na kailangan to. Bakit? Ito yung sinasabi ko, guys, na na i-difference natin. Difference x1 is equal to diff. So this is the function for differencing ng x1. Kaya tingnan natin. Okay, so our head will be Okay? So ito na yung difference data natin. So let's plot our difference data. Let's just use this, guys. Ito na lang. Okay, so let me just Control C, Control V, DX1. DX1. So let's see, let's plot yung DX1. All right. Okay, di ba dinifference natin? So stationary ba siya? Stationary pa rin, guys, no? Stationary pa rin. Now, is it necessary to have use differencing here? Hindi na, guys. Kasi original data natin stationary na eh. So it doesn't make sense, guys, if you difference the data when it's already stationary. Okay. The simpler, guys, the model, the better. Kasi this will entail another process, yung differencing. And mas mahirap i-interpret, guys, si difference data kaysa dun sa original na data. No? So the objective here is do not just difference. No? Kaya lang naman natin, kaya lang tayo nagdi-differencing, guys, if the data is not stationary. So this exercise, this one, was really an exercise in futility. Hindi natin kailangan to. Okay, so this is just another example. Okay, gawin na lang natin tong. Okay, ito, set that sheet ulit, 1, 2, 3. We're creating this object sim. And then ito, AR1 lang, ano? AR1 lang. Okay, list AR is equal to 0.8. So this is just the first one. So ano lang to, yung log 1 lang. So we are generating a data set which when we model it, we can just use the first log of the model of the data series itself to model our data. Okay, so let's run this. Tapos i-plot na rin natin. Okay, so ito yung view. Tapos yung generate yung plot. Okay, so ito yung plot niya, no? Okay, guys. So, look. Tingnan natin. Ano yung mean nito, guys, is practically 0. So, do we have a stationary data here? Is a data stationary in mean and in variance? Answer, yes. Okay, wala siyang trend. And stationary in variance, yung variance natin, hindi siya nagbabago across time. Although, if you take a look at this, parang merong konti, ano? Towards the later values, medyo may nag-i-increase ng konti, but just slight, no? Slight. So we can say that if this is stationary or not. And then let's just use separate yung HCF at saka PACF. Okay, we can use, para mas madali, guys, mas madali yung ito. Let's just use this. Let's just get the autocorrelation of the sim. Okay, so dito ko siya i-run. Nasa plots, let me see. Ayaw. Okay, copy ko na lang to. Naran ko na ba yung, yan, okay na yung sim. I'll just put it here. Okay. Okay, bakit hindi siya nag-run? Yan. Yan siyang kailangan idalawa. Okay. Take a look at this, guys. Ito yung sinasabi ko sa inyo kanina. Di ba nag-simulate tayo ng AR1 process? Di ba? How do I know na AR1 siya? Yung model natin. Di ba? Tingnan niyo yung ARIMA.sim natin dito. Yan, di ba? Ito, no? ARIMA.sim, yung model natin, list is equal to AR component 0.8. Ito AR1 lang, di ba? AR1 lang. So, if we take a look at our plot, okay, tingnan nyo guys. Is this indicative of an AR1 process? Yes. Kasi di ba paano natin malalaman kung AR1? We'll take a look at the PACF. Yun. Di ba? Significant at log 1. And no more significant at the rest. No? And then si ACF natin, slow decay siya. There. Ito yung sinasabi ko sa inyo guys na ang AR1 process will look like this. Yung partial autocorrelation niya, significant at certain logs. And then yung ACF niya will be significant at will be short, slow decay. Okay, let's now, sige, ano natin to put side by side na lang natin dito. Compare lang natin guys sa tagal mag-react nitong ano ko. Okay, gawa tayo nito guys. Nalang buo. No? Control C. So, sige, dito ko i-run. No? Okay. Let's call it some simulation. Lagay ko simulation MA. Dapat maganda dito simulation AR. Pero anyway, tapos na. So this time, we're going to make it MA. MA naman. Hindi natin, okay, negative 0.7, kunyari. Okay? Okay. So dito, nag-generate tayo ng dataset. Ang tawag natin sa kanya, simulate MA. Okay, we can do that using the ARIMA, that's simulation from the stats package. Model is equal to list MA natin, negative 0.7. Okay, 1,000 observations. Then, i-run natin to. Okay, we should have the same values. Hindi ko na i-run yung, yung view. Plot na lang. Okay, take a look at this. Okay, so ito guys, mamamodel na natin to using ARIMA kasi non-stationary siya, no? Non-stationary in mean, non-stationary in variance. I hope guys, I cannot overemphasize the point that when you're modeling ARIMA, dapat guys, stationary yung data natin. Okay, if your data is not stationary, then we have to do transformation para magamit natin si ARIMA. Okay, so i-plot natin guys si plot natin si dito na lang, Control C, ilagay ko dito. Dito ko na ilalagay, Control V, simulation.ma. Hirap na mag-close. Okay, I'm going to plot this. Minsan hindi kagad-kagad mag-run. Okay. May problema talaga itong ARCO. Tama naman, di ba? Simulation MA, yes. Hindi siya na. Wait lang ha. Ayaw pa rin. I don't know what's happening here. Dito ko siya i-run. Ayan. Tagal lang talaga. Kailangan talaga patience dito sa ARCO. Alright, take a look at this, guys. Tingnan yung difference ng ng MA at saka AR process. Okay, 'di ba? Nag-simulate tayo ng MA process, 'di ba? And remember, guys, ang MA process, we're using past error terms to model the time series. Okay, pag MA, ang tinitingnan natin yung ACF. Okay, take a look at this. Significant spike at log 1. And then dun sa iba, wala na. Meron ding konting dito, no? Konting significant spike dito. And then take a look at the PACF, slow decay. Yun, slow decay. So this is indicative that this is an MA model. No? Okay, pause muna ako. Any questions, guys? Nililipat to. Paki-chat naman please kung clear so far. Palitan ko to ng AR. Para mas clear, simulate AR. Okay. Alright. Dalawa pa lang kung clear. Yung iba, guys, paki-chat naman please. Galing ko na ito. Sorry binireposition ko itong mga nagsasama-sama ko na lang. Okay. I'm just fixing my notes. All right, thank you. Although apat lang guys yung nag-chat. Let's just give a few more minutes sa ibang classmates natin. Okay, wala nang comments, guys? All right. Okay, so here's another example. So here I'm creating an object, ARIMA10. Okay, ARIMA, then ito ang ginagamit yung we're going to use, okay, yung simulation natin, ginawa ko tong, okay, sim pa rin, no? Dapat simulation R na to. Okay, sorry about this, guys. If you're following along, if you're changing the nomenclature, yun. So may simulation AR na. Okay, yun yung gagamitan ko dito. Okay, what does the ARIMA function? What does the ARIMA function give us? ARIMA, tingnan natin Ano yung ARIMA function? Ito, from the stats package also. It is fit an ARIMA model to a univariate time series. Ganun din, no? Ganun din. Mag-fit tayo ng ARIMA model to a univariate time series. Sige. Okay, tingnan natin Alright. ARIMA. Tapos ang ginagamit natin object, sim AR. Ano ba yung sim AR? Di ba simulated yan na ang AR natin, AR1 component natin is 0.8. In other words, guys, yung data natin, y sub t is equal to a certain mean A sub O plus 0.8 times y sub t minus 1. Y sub t minus 1 plus a certain error term. Okay, so ito yung model na yon, no? Y sub t is equal to a certain mean average ng data natin plus 0.8 times y sub t minus 1. Kasi ito yung AR component na na pinasimulate natin. Now let's see guys, let's check, no? Let's check ito. We're creating this object ARIMA10 and the function is ARIMA. Anong data ang pinapaan natin? Simulate AR. And then order is equal to 100. Ano ibig sabihin nito? Ano ibig sabihin itong 100? PDQ, di ba? P stands for your AR component. 0 stands for kung may difference siya o hindi. And 0 here is the MA component. Then include that mean is equal to true. Okay? So sige, i-run natin to. No? Let's run this first two. Control Enter. Okay. Then what do we have here? Ano makikita natin dito? So sabi kasi natin mag-determine ng ng ARIMA model, no? Okay, anong ARIMA model ang pwede natin magamit for this object, itong sim_r natin. And then ang order niya AR1 process lang, no? So C100. So we're saying that i-model niya tong sim_AR na 100 na AR1 process. And then isama niyo yung mean. Ang result ng guys ito. So you have this AR1 coefficient 0.77 which is very close to the 0.8, di ba? Ito yung AR1 component plus the mean. So actually ang equation natin ito, yung A sub O natin dito is 0.1153. Control C, Control V, and then itong 0.772, Control C, and then Control V. Yan. That's our model, guys. No? Y sub T, actually ito yung dapat sim AR sub T, okay, is equal to sim AR T minus 1. Pasensya na guys sa dapat naka T minus 1. No? Ito, sim R sub T is equal to your intercept or your average simulated AR, okay, plus 0.77 times your log 1, your sim R T minus 1, plus your error term. And then here we have your standard error and then your standard error for your intercept. Then you have here some measures, the variance at 1.006, log likelihood, at saka yung AKIK information criterion 2850. Yung AIC guys ginagamit when you're comparing models. The lower AIC, the better. Okay, clear so far, guys? Clear so far? Okay, let me insert something here. Okay, mag-insert ulit ako dito, guys. Dito, Control C. Control. Okay. Gawin natin ARMA 11, no? Kanina ARMA 10, ibig sabihin log 1 yung AR component. So using the same data, guys, order natin is 1. Yan. Order is equal to AR component 1, MA component 1. Okay, this is let's call it ARMA 11. And then let's run this. Okay, so what do you notice now, guys? What do you notice now? Okay, so sabi natin, mag-generate na siya ng model na ARIMA. Ang gamitin niya, ARMA 11, no? Paano naging ARMA 11? 1 log 1 ng AR process, log 1 ng MA process. So nag-generate siya nito, no? AR1 0.776, MA1 0.008, tapos intercept 0.1151. And the AKIK here is 2852. Dito yung AKIK 2850. No? Okay, so ang tanong, sino mas maganda dito? Sino mas magandang model? Yung AR model, AR1 model, or ARMA 11 model? So currently guys, i-base lang natin dito no sa okay, before that. So if I'm going to write the model here, okay, you'll have y sub t or sine r sub t is equal to 0.1151 plus 0.7769 sine r t minus 1 plus error term at time t minus 0.008 error term at t minus 1. So this is the log 1 of your error term of your residual. So yun yung model natin if it's an ARIMA 11. Okay, pause muna ako guys. Pause muna ako kasi baka mahaba na yung dinidiscuss ko. Let me check guys kung okay lang. Kindly chat please. Yes. Kung clear so far or no if you want me to repeat something or discuss again. Please don't be ashamed guys kung gusto nyo i-discuss ko ulit. Okay, thank you. Let's wait for the others. I hope the others will also give their feedback. Okay. Justin from where? Sime AR. Okay, sige. So let me repeat guys the discussion. Thank you so much guys. Appreciate yung mga questions nyo. No? We're here to learn. Okay, so ito yung Sime AR natin. Bali yung kanina lang, linagyan ko lang ng underscore AR para mas naging, just to distinguish it from the simulated na MA. View, simulated AR, okay? Pinalitan ko lang lahat ng Sime kanina ng Sime AR. So binago ko lang yung name. Okay? Did that answer your question? Sino yung nag-question yun? Jiska? Okay, thank you. Okay, good. All right, ulitin natin yung yung ARIMA. No? Ulitin natin yung ARIMA. Guys, iba yung ARIMA.sim. Yung ARIMA.sim, mag-create ng data. No? Yung ARIMA, gagawa ng model. I-identify niya kung ano yung AR at saka kung AM. Depende dun sa order na pinirequest nyo. Okay. So, dito guys, gumagawa tayo ng isang model. Ang tawag dito, ARIMA10. Just to conveniently name this. Bakit 10? Kasi log 1 for the AR process and nothing for the MA process. Okay? So by now guys, dapat kabisado niya pag AR, how does the equation look like? Y sub t is equal to a certain constant a sub o plus a sub 1 times y sub t minus 1 plus a sub 2 times y sub t minus 2, etc. So we're using the past values of the data itself to model our data. Pag MA process naman, we're using the error terms, no? Ano yung error terms na yun? Yung actual value minus the average. No? Minus the average. Yun ang tinitingnan natin. Yung difference ng actual at saka ng average niya, yun ang residual natin. Yun ang epsilon sub t natin. Okay? So we're getting the difference of that. That's your error term. No? Okay, so dito guys, again, the ARIMA function will generate this one. Ibibigay sa atin yung component ng AR at saka kung ano yung pinaparan natin, no? Okay, so ito 100 kasi AR1 component lang. Nung rinan natin dito guys, di ba, ang lumabas sa kanya, ito. Okay? Of course guys, pwede nating baguhin to, no? Pwede kunyari gawin kong 2 ito, no? So, lang natin to same name na lang. No? Paano yung sinasabi ko, mag-generate siya ng ARIMA model na 2 logs ng AR at saka 2 logs ng MA. So if I run this, control enter, okay, tino yung i-generate niya. Yun. Yan, di ba? May AR1 component, may AR2 component, may MA1 component, may MA2 component. Bakit? Kasi 2 ang sinabi ko eh. Diba? Log 2 ng AR process, log 2 ng MA process. Okay. Pero ang tanong guys, mas okay ba tong model na to kaysa dun sa 100 model? Okay. If we're just comparing it on the AIC, no? Itong AIC na to, 2856 kanina, yung 100, 2850 yata, no? 2850. So we know guys that for AIC, the lower the better. So mas maganda guys yung ano, mas maganda yung 100 because of pag-parsimonious yung model. Hindi naman ibig sabihin na mas marami tayong linalagay na predictors as mas okay na, di ba? Okay, so let me go back to 1 here. 100 and then i-run ko ulit to. 2856 yung kanina, ito 2850 lang, no? So it turns out mas maganda yung ano, yung AR1 process lang. Okay? All right, what will happen guys if hindi, kasi kunyari hindi natin alam na simulated tong data na to. Okay? We don't know that this is a simulated data. So what we're going to do is i-guess ko lang na 001 siya. Okay. Although, di ba, nung pinat natin yung PACF, ACF, medyo may idea tayo na AR1 process yun eh. No? Okay, sabihin natin na misread natin. Ang pagbasa natin dun sa ACF at saka PACF, mukhang MA process to. Okay, sige, i-run natin as an MA process, no? MA1. Pag-rinan natin yung guys. Okay, tingnan nyo guys. MA1, 616, intercept ito. However, guys, tingnan nyo yung AIC natin. 3210. Kanina 2850 lang. Right? Di ba? Oh. Okay, tapos later on, magda-diagnostics side. Titingnan natin kung okay yung model na to. Pero definitely, guys, since we have tried an AR1 process, ang AIC niya 2850, tapos we also tried an MA1 process, ang AIC niya 3210, then we are quite confident that mas maganda yung AR1 process kaysa sa MA1 process, no? By virtue of the likelihood yung sa information criterion. Okay. Now there's another function, okay, AR. Ito guys, ito yung pinaka ano, ito na yung tingnan natin yung auto.arima, no? So I'm going to type here auto.arima, question mark, auto.arima. Okay. So this is coming from the forecast package. I-library pala muna natin, ano? Okay. Forecast, hindi pa natin naloload to. Okay. All right, take a look at this. Fit the best ARIMA model. Okay. So dati guys, yung ARIMA function, limited tayo dun sa isa-isa lang, no? Limited tayo. Mag-identify ka muna, 100 ba yan, 101, 201, etc. No, dito sa auto.arima, pwede nang siya mismo maghanap, no? Okay, so auto.arima. So let's, I'm going to load library first. Hindi ko pa na-load. Forecast. Okay, so na-load ko na yung forecast. And then, okay, tingnan nyo to. Forecast, function, package, auto.arima. Anong object? Simulation.ar. And then trace is equal to true. No? Trace is equal to true. Control, enter. All right. Tingnan nyo to guys. No? Nagbigay siya ng mga ano, ng mga suggested na ano, suggested na mga models, no? Suggested na mga models, okay? Yan ang ibibigay niya pag trace is equal to true. All right. So let's take a look at this. Sabi niya ARIMA202 with non-zero mean, walang mean. 2851. Okay? Ito yung ginawa natin kanina, no? ARIMA100, non-zero mean 2848.021. Okay? So you have a list here of different models. ARIMA201, 001, 101, no? Ito yung kaninang ginamit natin, ARIMA100, walang mean ang iaano, Tapos meron ding ARIMA 100, okay, with non-zero mean at saka with zero mean. Ito, no? 2846. So among all of this, guys, among all of this, lumalabas dito, guys, na mas maganda yung ARIMA 100 without the mean. So ibig sabihin nun, wala yung A naught natin. Saan yung model natin kanina? Ito. Wala yung A naught, wala yung intercept, no? 2846 yung AIC. Okay, 2848. Okay, so apparently the best model is this one. ARIMA 100. Okay, so sige. So ganyan, guys, ang kagandahan ng ito sinasabi pa, oh, refitting the best model without approximations, no? So ARIMA, okay, with zero mean 2848. Tapos best model is ARIMA 100 with zero mean. Ang components niya ito. Here. Okay, this one. So using that auto.arima, guys, kita kagad natin kung ano yung model natin, no? AR1 component lang daw. Tapos walang mean. So how will this model look like? So this model will look like this. So yung model na to magiging yung object natin is sim AR sub t, sub yan, guys, is equal to, okay, wala tayong wala tayong intercept, wala tayong constant mean. It will become 0.7783, okay, times simulate AR t minus 1, di ba? T minus 1 siya kasi that's log 1, and then plus a certain error term, epsilon sub t. So this is our best model dun sa sim R na simulated model natin. Okay? Take a look at this. Diba? Okay, pause muna ako, guys. Any questions so far? Okay, chat naman, guys, kung clear. Okay, isa pa lang. Let me wait for the others to give in their feedback, please. Okay, apat lang yung feedback. Sana makalahati mo lang yung feedback, guys. Yung true feedback, yung talagang sinusundan niyo yung Okay, I was hoping that more feedback from you. Okay, all right. So what we have learned, guys, is using the ARIMA function and the auto ARIMA function. Yung ARIMA function ginamit natin, guys, in order to develop a model, guys, for our time series. Okay, di ba ito yung ginamit natin? Let me just copy this. So ito, guys, ano din to, no? Let me revert back to one. Okay. Ibalik ko to kasi baka 0. So this is an AR1 process, no? Tapos kanina nag-include that mean is equal to true tayo. Pwede rin natin tanggalin yan. False. Okay? Kasi nalaman na nga natin na based on the model, yung ARIMA 1010 with no mean, yun ang magandang model. Okay, run natin to. Then ARIMA 10, print natin. Yan. Alright? Okay, so 0.7783 Pareho dun sa auto.arima kanina. Okay, yung standard error the same. Dito nga lang medyo magkaiba yung AIC 28, tama, 2848, no? 2848, yan, 0.98, parehong-pareho, no? Okay, and that was the model suggested by your ARIMA function. So, best model, okay, ARIMA 100 with 0 mean. Okay, 2848.98. Okay, so that could have been also generated using yung ARIMA, no? Kaso nga lang, ang advantage ng auto.arima, guys, siya na mismo, pag iti-trace is equal to true nyo, kasi pag hindi nyo i-trace is equal to true, so let's try to run this. Na walang trace is equal to true. Yun yung result, guys. Hindi niya pinapakita, no? Hindi niya pinapakita yung ibang models na tinignan niya. Yung isa lang, yung best model lang pinakita niya. ARIMA 100 with 0 mean. But if you want, guys, to know, okay, to know the other models para may comparison, then you have to include trace is equal to true. Okay, it's almost time. Let's see how far we can go. Okay, now it does not, guys, hindi natatapos doon, no? Nakapag-generate tayo ng ng model. Okay, ulitin ko lang tong ARIMA 10 natin. Okay, let me run that. Okay, include is equal to, sabi natin, di ba? Include is equal to false. Ito yung pinakamagandang model. So hindi tayo magsasama ng hindi tayo magsasama ng mean. Ito siya. Alright, so that's our model, di ba? Lagay ko dito, final model. ARMA 10, okay? Or ARIMA, pwede rin to, ARIMA 100. Pare-pareho lang yan, guys, no? ARIMA 100, ARMA 110, or AR1. Equal yan to ARMA 10. Equal din yan sa AR1. So they're all the same, guys. They're all the same. So that was our model, ARIMA 100 without the mean, di ba? Okay, so what we're going to do next is ito yung model natin, yung pala, nasulit ko dito. Our model for simulation AR. No? So dapat to, okay, so okay. Alright, simulation AR. Hindi ko pwedeng gamitin yung underscore kasi yung underscore, guys, pag linalatex natin yan, it signifies sub. No? So ito yung model natin. Okay, so next, guys, alam naman natin na ang susunod is to do diagnostics. No? So let's create this object, residual ARMA 10. Okay, and it's from the residuals. No? Okay. So nag-create tayo, guys, ng object na residual ARMA 10. Okay? Now, kunin nga natin ang auto.arima natin ito. Tingnan natin kung pwede pa natin i-model yung residuals. No? So let's see. What I'm doing here, guys, is, di ba, nag-auto.arima tayo? Ang minomodel natin dito yung residual. Meron pa ba? Kasi dapat ang residual, guys, wala na dapat tayong ma-model doon. No? So let's enter this. Okay. Let's take a look at this, guys. Anong sabi niya, guys? Anong sabi niya? So, sinubukan niyang i-model 202, 001, etc. Now, ang best model daw is ARIMA 000 with 0 mean. Yan. Ang ibig sabihin, wala ng AR component, wala ng MA component. So, ang ibig sabihin ng ARIMA 000, guys, white noise na yan. Okay? White noise na yan. So, ibig sabihin, guys, tama yung model natin. Dapat yung residuals natin, guys, dapat white noise na. So ibig sabihin, hindi na tayo magkakapag-create ng panibagong model dun sa residuals. Kasi error terms na yun eh. Okay? Alright? Okay, so we'll stop there guys because it's already time. So next meeting guys, kung pwede guys, please go through this tapos we will be, yung iba notes lang naman dito, alam nyo na yan. Okay? Magpo-focus tayo dito sa last part. Ito. We're going to apply this to, i-download natin si Apple. Okay, mag-create tayo ng ARIMA model for Apple. Tingnan natin kung ano yung best model sa kanya. And then do some diagnostics for this. So may I request you guys to please go through the process. And tingnan nyo kung, kasi dito na guys yung ano eh, yung pati yung diagnostics, no? Okay, you'll have a project, of course, on time series. Okay, so let me stop recording.